Welcome, everyone. We are live. Let me know if you've seen any of the previous episodes in this little series. This is actually part four of I think, a 12-part series of just broad scale GRE prep advice. And the links to all the previous parts are in the description for this particular session as well. So if you are watching this in the future as a recording, you can find links to all of the previous ones as well. I actually did the first one, which was just a very grounded idea of how do I plan my studies from the very beginning to the very end. Today, we are focused on a quant content which shows up incredibly frequently on this test. Today's focus, all percentages are the same, but they're kind of not. They all come from one foundational relationship. And once you have that foundational relationship, we find that there are two ways to quickly address the most common presentations of percentage ideas. We are going to this problem. This is where we're going to end. And the reason I love this problem is because it highlights the two most frequent ways to deal with percentage ideas in one problem. Like I said, this is where we're going. Before we do this problem, though, I want to just talk through a few core elements here. All percentages are at their core the same. And the first thing to recognize is that they are operations, not numbers. This is commonly true of fractions as well, especially a fraction in a word problem, in a story problem, but it's always true of percentages. It's an operation, not a number. What that means for us is we always want to ask percent of what. And anytime you're dealing with a percentage question, make sure you have that percent of what somewhere on your workspace. There is one fundamental translation. We're going to look at that in just a moment. There are two variations on that fundamental translation, but your fundamental translation for percentages is always, it's a piece out of a 100-part division. And then finally, if percentages are not numbers, how do we use that to our advantage? And the idea is that if percentages are not numbers, we have the possibility that we may be looking at a problem that does not have numbers. And if you are looking at a problem that does not have numbers and does not ask for numbers, you get to choose your own. And choosing your own numbers can be an exceedingly advantageous thing on this test. So, first, percentages are operations, not numbers. This is not a complete problem, so don't worry about getting to an answer. I am quite curious, how would we translate this into mathematics notation on our paper? Everyone take a moment and consider how you would translate this into math notation. And if you have something that you would like to share, please throw it into the chat in just a second. I'd be intrigued to see what people suggest. I saw a student do this one time. 55, and I'll use X for fiber X. And I'll use M for fiber max. 55X plus 70M equals 65. So Bilal is suggesting convert them to decimals. So maybe we would say, look at this and say, those really should be decimals. So it makes it 0.55x, 0.70m, and 0.65. But there is still something missing. What is missing from this translation? We're missing the percent of what? that 0.55x is 55% of whatever amount of x you used. That 0.70m is 70% of whatever amount of fiber max that you used. Abandon all hope is giving a very hopeful response. That 0.65 at the end needs to be 0.65 of what? Of the total amount of cereal that you are using. And so this is how you could generate a mathematics relationship for this problem. Percentages are operations, not numbers. Always have a percent of what component settled in your head. I really want to know that abandon all hope username. That is just that is a very fascinating name, and I'm wondering where that first came from. I'd be intrigued if you could just for my own personal curiosity, when did you start using that username? But in the meantime, one fundamental translation for percentages. How would we translate both of these? You got it from a TV show. Interesting. Oh, wow. All right. Now I'm 45 years old. There was a show in the 90s called Space Above and Beyond. Space Above and Beyond had a reference to that. He saw the quant scoring curve. Yeah, that would do it. It is a literary reference from Dante's Inferno, I believe. Abandon all hope, ye who enter here, is one of the first things that your protagonist comes across in his journey into the Inferno. I think that's like going back to my high school language arts classes. Yeah, Chisholm. I'm pretty sure it's Dante's Inferno. One fundamental translation for percentages. What is X percent of Y? You are saying there is some Y. Wow. PowerPoint does this wonderful thing where it switches off my pen tool sometimes, and I don't know why it does that. So you have this fundamental thing of Y, some base value. And if you're taking X percent of it, you are taking that X and basically carving that Y, that base value, into 100 pieces, and you're taking X number of those 100 pieces of Y. Yep. Of means multiply, percent means per 100, so we do it per 100 over Y. What is X percent more than Y? Well, you do still have this idea of an X over 100 times Y. That fundamental translation does still hold. But what else is existing in that X percent more than Y? We have this idea of if it's percent change, you are taking your piece, that X percent of Y, and you are applying it back to your base value. So this would be Y plus X over 100Y, which commonly, if we're doing an algebraic representation, you would commonly factor out that term Y and rewrite it as Y parentheses 1 plus X over 100. Everyone take a moment. Try this problem. Type in an answer choice whenever you have it, please. I want to make sure that everybody has enough time to consider the problem. Whenever you're ready, give me a few answer choices in the chat, or just tell me done in the chat. That would also be fine. Abandon all hope. You typed in y x over 0, 0 times y. Are you referencing back to this page? This x percent of y, it's a, yeah, there we go. Yep. So in this thing, x percent of y, your y is your base value. And so you're always, this percentage is operating on that base value. So it's operating on the y. So like here, it's operating on the y. And this x percent, that's it. It's a translation that we can just apply it to all percentages. It's always something over 100. Anyway, add y since more than, just why not the percentage multiplied to y? You know what, in the second version, just why not the percentage multiplied to y? Because if you want to get x percent more than y, this is a common GRE phrasing when they want the total value after all the calculations are done. It's one of the more frequent things would be like in an interest problem where you've got a principal and an interest rate, and they ask you what is the final value of the investment, and you apply that interest rate. So there's your x over 100 times y. But then if you want the final value, the interest earned on that investment is added to the original principal. And so this is the GRE phrasing, what is x percent more than y, when they want the final total value, your base value, and the percentage that you increased it by. Coming back here, the point for this problem, if percentages are not numbers, how do we use that to our advantage? We use this to our advantage by choosing a number. And Bilal is suggesting that we pick 100 as a starting number. So let's take a moment. Let's build this out. Those were not two connected questions. Abandon all hope. They were just separate ideas. So we have my total shirts in the closet. I have my shirts that are white. I have my remaining shirts. Be careful for that thing that we have there at the end, the remaining shirts. And then we have our shirts that are gray. So if my total is 100, I have 50 white shirts, which means that my remaining shirts would be the other 50. And how many shirts are gray? What is 30% of 50? You have 30% of 50 is 15. Again, if you wanted, you could set that up as 30% of 50. And do all your cancellations, you get 15 there. So my white plus gray shirts is 65 total shirts. The percent that are not white or gray would be the remainder. That would be 35 out of the 100 shirts, which is 35%. Choice A is larger. If percentages are not numbers, how do we use that to our advantage? We have the opportunity to choose the numbers that we want. And now we come back here. Everyone take a moment. See what we can do with this problem. Type in done when you are done, or you can type in the answer choice you would select. Just want to make sure that everybody has enough time. Let me know when you're done. One thing that I like to do is I like to work from organization before I work from mathematics. In fact, we saw that in the approach here. Set up a chart just to track the different components. And in fact, what I commonly do is I will actually show the intervals. Taking 50% of that, taking 30% of that. I like to show the intervals. That's something that I do very, very often. Here, I have a problem where I have 3 stages of a number. I start with 150. I'm going to increase that by 60%. And then I'm going to decrease that result by Y%. And by law, I believe 20 is the answer, yes. And I know that my final result is going to be 192. Well, where did the 1.6 come from? You say 150 times 1.6. Where did that come from? Yeah, increasing by 60%. What we have here is we've got 2 stages, 2 separate ways to tackle these types of problems. Stage 1 is when I know the percentage. So doing that, when the percentage is known, I can convert that 60% to its decimal format. Then you're seeing, again, this fallback to that core translation, this idea of your percent more than is a 1 base value, and then you change it by that amount. So I can do 1 base value plus 60% of that base value, and that's going to be 1.6. So I multiply this by 1.6, and I will get 240. Then to do that 192, and now I'm feeling paranoid. I'm going to go ahead and grab the calculator to make sure, yes, 150 times 1.6 is 240. The other variation on on percentages is when you don't know the percentage, but you know the values. And so in this example, where I know the values, I can rely on this almost sort of a definitional idea. Domenico, welcome back. I remember you from a previous lesson that I did. At least I think I do. When we know the numbers but not the percentage, we can fall back to just using the numbers to find a percentage. And that's close. 240 times y equals 192. And then y equals 0.8. But E is not actually the answer. This is the trap for this kind of thing. We have to be aware of percent change versus percent of. 192 is 80% of 240. But when you have a percent increase or a percent decrease, it's always about figuring out what was the change from your value. The way that shows up when I know the percentage is this percentage is applied as a change, an addition from that one base value. Here, this is going to show up as actually a subtraction, a difference. And so you can work with percent change as the difference divided by the base value. And so we can look at that as 240 minus 192. Now, which one is the base value here? The 240 or the 192? The base value here is your 240. This is why I like to draw the little arrows, like to show my intervals. When I show the arrow going 240 from 240 to 192, and I decrease that by y%, the origin of the arrow is my base value. 240 minus 192 is 48. And when I do that math, I get 0.20, or in its percentage format, 20%. And so we end up with actually answer choice A. So what we're seeing here is that a percent of relationship will always be a straight multiplication. X% of y is just x to 100 times y. A percent change will always involve some difference, some addition from or subtraction from some base value. So what we have here then is the two most frequent ways to tackle percentages. If you know the percentage but not the number, everyone should take a moment. So here, if I have 20% of x, I can just take that decimal form of 20%, 0.2, and then apply that directly to x. 4% change. If, for example, I have 30% less than y, I would take that decimal form, 0.3, and subtract it off of 1 because I'm going down to get 0.7. And so 30% less than y would be 0.7 times x. Can I illustrate that last point? Are you talking about the last point in this problem? No. Okay. It seems that we're okay. Abandon all hope. Oh, the last point here on this screen. I think I understand your question now. That 30% lasted why? Yep. So that is how we tackle a percentage when we know the percentage. This is actually by far my preferred presentation. I like to be able to just know the percentage and just be able to apply it. That feels far more direct to me. That's not everybody. That's just my own personal preference. If I know the number but not the percentage, for percent of, you can just use the definition piece divided by base value. So for example there, if you had 10 is what percent of 40, you can just say, I'm going to do 10 divided by my base, and then that turns into a decimal. It becomes 1 over 4.25, which is the same thing as 25%. If it's percent of, and I know the numbers, the piece that I'm talking about divided by the base value. If I'm looking at percent change, the variation on that becomes difference divided by the base value. So if you have 10 is what percent less than 40, you would take your difference, a difference of 30, divide that by the base value. We're basically starting at 40 and going down to 10. 40 is my base. Convert that into my decimal format, which then becomes my percentage of 75%. These are our two most frequent ways to handle percentages. And in fact, I would argue that if you're on the test, they should be the only ways that you handle percentages, because you either know the percentage but not one of the numbers, or you know the numbers but not the percentage. If you don't know anything, if you don't know the value of the numbers and you don't know the percentage, just choose your own. That is, again, the idea that percentages are not numbers. And so if we have a problem, we're not given any numbers, we can just take advantage of that fact. Last thing here is that some percentages are couched in a story presentation, which is a disguised interest rate. Interest or percent, like a percent increase in stages, these are not different. Everyone take a few moments. Type in the chat when you're done. You can either say done or just let me know the answer you would select. Again, I want to give everyone time to fully consider the problem. Bilal is asking, Can you talk rules regarding adding and subtracting percentages? Interesting question. Let's see what we have. So let's bring my pen tool back. Let's set up this problem. And again, I'm a big fan of working from organization for math. I have a colony of bacteria, a really very pleasant problem, right? And it increases by 20% every 3 minutes. And we are going from 8:54 a.m. to 8:57 to 9 a.m. So by law, adding and subtracting percentages. So I look at this and I go, okay, so I have two 20% increases. So I can say, fair enough, this is a 40% increase. Why does that not work? Open question to anyone. You cannot just say that's the same as a 40% increase from beginning to end. What's wrong with that idea? +20 plus 20 is 40. That does not work because your different percentages do not operate on the same base value. Whatever number exists at 8:54 is not the same number that exists at 8:57. And so this 20% on this number will give you a different result than this 20% on this number. 20, let's say for example, this is 100 and this becomes 120. 20% of 100 is not the same as 20% of 120. So rules regarding adding and subtracting percentages. The rule is you can add or subtract percentages if your multiple percentages operate on the same base value. However, my rule is don't. It is very, very easy for them to build traps whenever we try and build shortcuts into a problem. So I say, let's just not worry about adding and subtracting percentages. Let's just go ahead and do the percentage as stated. So we are not going to do this increase by 40%. What we could do is we could start this up and say, I have some population X. I don't know what it is. How do I mathematically define a 20% increase? How do I do that in one step? What is the factor that I will multiply by? Multiply, let me not use a multiplication symbol there. Let me erase that in these parentheses. So don't confuse the X there. Convert that 20% into its decimal form, 0.2. Add that on to 1 to reflect the fact that you are increasing from that one base value. Multiply this by 1.2. And so I will have 1.2x and then 1.44x. I am told that 1.44x is 144,000. That was meant to be an equal sign. When I divide by 1.44, I get 100,000 was my X value. Why is it 1.2 for both? It is 1.2 for both because it is a 20% that gets it's increased in stages. And so at each stage, you are doing another percent increase on a new value. and it's the 1.2, your 20% in a decimal conversion is 0.2. So you're doing one base value. You are doing an x plus 20% of x. Factor out that common term of x, and you get 1.0.2, which is the same thing as multiplying x by 1.2. Is it possible to go in reverse? It is. And in fact, that's what I love to do with these types of problems. But don't try to reverse the percentages. This comes back to a fundamental idea that a percentage is not a number, it is an operation. So that 20% is not the number 20. A 20% technically isn't even 0.2, and a 20% increase isn't 1.2. It's an operation. And of course, why would I even bring it up? Yes, absolutely. I love the politeness of the request. But if you want to work in reverse, you have to reverse the operation. Don't try to reverse the number because the percentage isn't a number. What is the operation of multiplication? How do you undo a multiplication? You undo a multiplication by dividing. So you can divide by 1.2 twice. Still just a percent problem. And again, I love the fact that it really relies on this idea that remember that the percentages are not numbers. So don't try to take that 20% and try and go backwards by doing like 80% because it's not a number. It's an operation. Reverse the operation and you will arrive at your correct answer. They wanted 854. They wanted my original X. My original X is 100,000. This, my friends, is everything percentage that you will ever see on this test. And I want to take a moment. I want to come back here. Know this page. And yes, it's 1.2 both times because it is two different 3-minute increments. This is actually a disguised, it's a disguised compound interest problem. You take an interest rate, apply it to a principal X, and every single period of time, you are applying that interest rate again to the new base value. If you know this page, you can quickly and efficiently tackle any percentage translation they will ever throw at you. All right, my friends. I hope you've enjoyed this. Do we need that interest rate formula? I have never needed an interest rate formula on the GRE. What I do need to know is I need to tackle interest rates as percentages, just like we did with that population of bacteria question. The other thing that I might need to know, and I'll be honest with you, I cannot recall seeing a GRE problem that actually forced me to deal with this. But I have seen GMAT problems that forced me to deal with it. And the GMAT and the GRE are starting to become very, very, very similar in the way that they treat some of these topics. And so you might get a compound interest problem where it says like an 8% annual interest rate compounded quarterly. And what you need to know that is that an 8% done quarterly isn't 8%, 8%, 8%, 8%. It's a different definition of annual, where basically you take that 8% and divide it up into 4. So it'd be a 2%, 2%, 2%, 2% set of interest rates. There are lots of things you're going to see in books that are very, very, very algebra heavy. And my personal thing is I don't want to memorize lots and lots of minute equations. I want to have a few core principles that can be applied broadly across any variation of a content area that I know they're going to test a lot of. Percentage questions, these two formats can get you every percent question on the test. You were a politics major? Yeah. I work with a lot of people who have been, for whatever reason, whether in their studies or professionally, they've not been math focused for a long time. And we got to take some time to get back to some of those foundations there. If you have enjoyed this, if this has felt informative to you, remember again, this is part 4 of 12. There are 7 more of these coming along the way here. You got a few left of these. 8 more. Goodness, Chris. Wow. And if you subscribe, if you like, you'll be able to find these easily. You can also just take a course. Sign up for a class 1. You get that. Also, you can get GRE and GMAT starter kits, which are fantastic resources. I would actually recommend going ahead and getting both starter kits because you've got a lot of material that shows up in both, and that just gives you more areas to practice. So you've got those as well. Another thing that you all might be interested in as well is we do Foundations of Math workshops. You have a Foundations of Math workshop for computations and for variables. So you can go to manhattanprep.com and sign up for a Foundations of Math workshop. I actually teach several of those. I've done a couple in the last month. I'm actually going to be doing some more in November as well. And if you do decide to sign up for a class, make sure that you keep in mind this code here. You have the 2018 version of the 5-pound. That is not the latest one. We published a new version of the 5-pound book in 2023 or 2024. I'm glad you think so, Domenico. I certainly do as well. I certainly try to make sure that everything that we do for everyone that we work with is absolute top tier quality. I hope you all found today informative and helpful. Is that GRE? The math foundations? The math foundations, the foundation of the math workshop can be applied to any of the GMAT or GRE. So again, you get a starter kit there. Math Foundations is just test agnostic. It's the core math mechanics that we need no matter what test you're taking. And yeah, it is definitely relevant to GRE. How does that overlap with GRE courses? The Foundations of Math workshops are sort of like a pre-course idea where you can get the Foundations of Math workshops and have those done. And that gives you a very good foundation. I mean, we called it Foundations of Math for a reason. A very good foundation for when you do a course, makes everything that happens in the course feel easier and more automatic. It is supplemental. You can, the course can be done without it, but it's something that a lot of people find very, very helpful. And I wanted to mention it because they are free. And if you're looking for resources that are not going to be too expensive, they're great. But we will have a next week part 2 of reading comprehension. Hopefully you'll all enjoy that very much. And then subscribe here, like this, and that can help other people find it. And if the subscription to this YouTube account can help you find it, and make sure you get it there. You want it? Go to the Manhattan Prep page. There'll be some times of new Foundations Math workshops starting soon. You're going to see this posted pretty soon, probably by the end of next week. But you can go and look today and see which other ones are already posted. There'll be more posted, I think, probably by the end of next week. Reading comprehension, show up here next Thursday. And keep in mind as well that there was a part 1 of reading comprehension. The link to all of the previous workshops that we've done, all the previous seminars, this is part 4. Parts 1, 2, and 3. There are links in the description here. You can go find them. And so you can go look at the previous, I think it was last week or the week before, was reading comprehension. And you can see that workshop as well. Yeah, get that subscribe, hit that like. You get all these things. All right, everybody. That is our time today. Expecting us to remember details, that's the thing. You don't. The fundamental thing about reading comprehension is going to be that it's about the passage stays there, and you actually want to train yourself to be able to go back and skim to find certain details quickly. All right, everybody. Thank you all very much for your time today.